Welcome to Study Loop.
Okay, so in this question, we want to see if these functions are one-to-one functions. So the first thing that we know is that for all of these functions, one input is only mapped to one output. So we are good in the forwards directions. Now we need to go backwards. We need to show that if the outputs are the same, that is f as function of a is equal to b, then this implies that the input must be the same. So this is what we have to prove. So for a, f as a function of n is equal to n minus 1. You have f as a function of a is equal to a minus 1, which is equal to f of b, which is equal to b minus 1. So this gives you a equals to b. So therefore, this is a one-to-one function. Now b, f as a function of n is equal to n squared plus 1. So you have f as a function of a equals to f as a function of b, which implies a squared plus 1 is equal to b squared plus 1. So that gives you a squared is equal to b squared. So a is equal to plus or minus square root of b squared. So that's plus or minus b. So then this is not an onto function. This is not a one-to-one function, sorry. This is not a one-to-one function. Because even though the outputs are the same, you can have two different inputs, namely plus or minus b. So for example, f as a function of 1 gives you 1 squared is 1, plus 1 gives you 2. F as a function of minus 1 gives you 1 squared plus 1 again, which gives you 2. So two outputs get mapped by two different inputs. Now C, f as a function of n is equal to n cubed. So once again, f of a is equal to f of b, which implies a cubed is equal to b cubed, which implies that a is equal to the cubed root of b cubed, which is just b. So therefore, this is a one-to-one function. Now finally, d, f as a function of n is equal to ceiling of n over 2. So this is not a one-to-one function. To kind of do some arithmetic, this is very difficult to prove that a and b do not necessarily need to be equal for this thing to occur. Instead, what you could do is you can kind of guess values for which these will occur. So for example, let's see what happens f as 1. So this is ceiling of 1 over 2, which is just ceiling of 0.5. So that's just 1. Now what can also make 1? F of 2. Because this is 2 over 2, which is ceiling of 1, which is 1. So we just created an example where this thing does not work. So therefore, this is not a one-to-one function.